The emergence of 5G comes with many opportunities, but also presents new challenges for network testing. All phases of the life cycle are addressed by the Rohde and Schwarz mobile network testing portfolio, from spectral clearance and deployment to benchmarking, optimization, and monitoring. We empower our customers to make quality of experience-centric decisions, to deliver better services with higher quality of experience, and to reduce their time to market. Today, we focus on site testing. 5G comes with a few new challenges, including base station architecture, OTA connectivity requirements, higher frequency bands, and the necessity to test parameters such as latency and download speed. With the deployment of 5G infrastructure, each new installation must be verified to ensure network performance and quality of service. But with a well-defined testing procedure and the right testing tools, a reliable and efficient process can be conducted for both indoor and outdoor sites. Let's take a look at the different steps and the necessary testing equipment. The first step is spectrum clearance. This ensures a clean RF environment by eliminating external interference. By walking or driving the area using our network scanner, you can characterize the RF environment at relevant frequency bands and identify potential interferers. The next step is to locate the sources of the interfering signals. These sources can then be switched off or reported to a regulator. Next is the deployment and acceptance phase, including a number of functional tests. You can test the network connection and run performance tests for latency, download and upload speed, and more using a smartphone-based network optimizer such as the Qualipak Android. The G-Node B transmission in the time and frequency domain is visualized using 5G over-the-air spectrum measurements. Using a decoding receiver, the 5G and LTE anchor signals can be analyzed in more detail, including the presence and quality of RSRP and SINR, and by conducting advanced timing measurements like time alignment error. You can also troubleshoot specific parameters whenever necessary. Another important aspect is ensuring that the total radiated power and electromagnetic field strength is below the defined threshold. With 5G EMF measurements, you can determine the electromagnetic field strength using the right part of the 5G signal, preferably using the code selective technique. Once the network is operational, diagnosing and resolving technical issues is similar to the deployment and acceptance phase. First, a network problem ticket is created in response to poor network quality KPIs or a subscriber complaint. To diagnose and resolve network problems, you can then conduct the same 5G site testing sequence with functional tests, spectral measurements, and signal decoding as in Phase 2. Over-the-air testing is crucial for effective 5G site testing. Test tools with sensitivity down to -140 dBm combined with resilience to neighboring high-power signals are essential. With the R&S Toolbox, you are well prepared for the task.